Hi everyone, my name is Eric Leichtenschlag, and I manage the developer relations teams for both the Mobile Ads SDK and the IMA SDK. Today I'm here to share what we've been working on regarding native and video ad formats in the Mobile Ads SDK. I'd like to start off by talking about the changes we've made to support video across several formats in the SDK. The first format I'd like to discuss is rewarded video. Rewarded video is an opt-in user experience. As the publisher, you explicitly ask the user if they want to watch a video in exchange for an in-game reward. The user consents to watching the video, and if they watch to completion, they get a reward at the end. At GDC 2016, AdMob announced support for mediation of rewarded video ads. This means you could call AdMob's rewarded video APIs, and we would mediate to other rewarded video ad networks. We currently support 9 rewarded video ad networks in AdMob mediation today. At GDC this year, AdMob announced support for its own rewarded video ads, using the same API. AdMob's initial launch was only for app install ads, but we are actively working on supporting additional rewarded ad formats. On the DFP side, rewarded video for Google Demand is in alpha. Please reach out to your account manager to be notified when DFP rewarded ads are ready for beta. We plan to support reservations in the second half of 2017. So here's what AdMob app install ad formats looks like for rewarded video. There's a counter on the top right along with a close button, which gives the user the option to close the ad if they no longer want the reward. The user also has the option to click install at any point in the video. If the user clicks install, the video will continue playing through to completion so that the user still gets credit for the reward. Upon completion, the user will be taken to the Play Store. In the event that the user did not click the ad while the video is playing, an end card is displayed after the video completes. At this point, the user is eligible for a reward. Their options now are to click install or to close the ad. So that's it for rewarded video, but we've also added video support to our native advanced formats. The Mobile Ads SDK has 3 native ad formats. App install and content ads are the 2 formats that have Google Demand. For DFP publishers, we also have custom native ad formats, which allows you to pass arbitrary ad data to your app using DFP reservations. All 3 of these ad formats now support native video, but I plan to focus on how you can enable video ads specifically for app install and content ads. First, let's talk for a second about native implementation without video. An app install and content ad both always provide an image asset, and although you're not required to display the image asset, most implementations do use it. The screenshot on the right shows a sample layout of a native content ad. We think that the common use case will be to replace the image asset with the video asset, so we wanted to make it as easy as possible to turn this layout into this layout with the video asset. Now, not all native ads have a video format, so we designed this special asset called Media View, which displays the video ad if video is supported, or an image from the native ad if no video content is available. Now I'm going to walk through some code on how to replace the image view with this media view on Android. The code to make an ad request doesn't change, and the code you see here happens once the native ad is successfully loaded. When rendering the native ad, we ask you to tell us which view corresponds to which asset, so we can handle impression click tracking. Previously, you would tell the native ad view about your image view by calling the setImageView method and passing the view that hosted your image asset. With native video, you will replace that code with code to set the media view. The setMediaView method is a little special in that it requires a media view object, which is defined by the Mobile Ads SDK. The setImageView method accepted any Android view. Since the findViewById method in Android returns a generic view, we need to cast it to a media view in our setMediaView example. Now that you told the Mobile Ads SDK about the view, the next step is to actually set the data inside that view. With the old ImageView implementation, you would need to get the drawable out of the native ad object and populate your image view with that data by calling setImageDrawable. With the media view, the SDK automatically populates the asset for you, the video asset if it's a video ad, or an image asset if it's a non-video ad. So no additional code is required to actually populate the media view. So that's it for getting media view in your app. But now that there is video playing, you have additional options to customize the playback experience. Every native ad has a video controller, and that video controller tells you whether or not the ad has video content. If it does, you can register for a callback when the video ends by setting the video lifecycle callbacks as shown here. You also have the option to decide whether video ads should start muted. The SDK exposes a video options class where you can set this property. Video options are set inside of native ad options, and native ad options is set as part of the ad loader that you build. By default, native video ads will start muted. So this example shows you how to make the video start playing with sound. That's it for native video and native advanced, or custom rendering for you DFP publishers. The last format for video that I'd like to talk about is the video within AdMob Native Express. In AdMob Native Express, we've recently added video to our native app install format. You can enable video app install in Native Express by going to your Native Express ad unit settings in the AdMob UI and selecting a checkbox for the new format. With Native Express, there is similar functionality to specify whether video ads should start muted, and also to register for the video lifecycle callbacks in the same manner as I just discussed for Native Advanced. So that's what we've been up to with video formats. Now I'd like to switch gears and talk about mediation, and I'll start off talking specifically about native mediation. Last month, AdMob announced support for native mediation with 4 networks: Facebook Audience Network, Flurry, MoPub, and Enmobi. It is available for all publishers who are currently whitelisted for native ads from AdMob. For DFP, native mediation is currently in beta. You can reach out to your account manager to request being enabled. And finally, the native advanced video features I discussed in the previous topic are not yet available for mediation. But enabling third-party native video demand to serve within native mediation is on the roadmap, and we are actively working on it. Speaking of mediation, I'd like to talk about what we're doing to make it easier to improve the mediation developer experience. First, we are changing our engagement model with our ad network partners. Historically, the engagement model Google had with these third-party ad networks is that they would host and maintain the adapter. One problem we've seen is that the adapters would occasionally get out of date. If the third-party ad network didn't prioritize a fix, the Google mediation experience suffered. We're fixing this approach by moving the adapters into a Google-owned open-source repository, starting with a few popular ad networks. Doing this has several benefits. First, the Google and the third-party ad networks have a shared space to collaborate. The third-party ad network understands their SDK best, but Google understands best how the integration fits in with the rest of the mediation experience. Having 2 pairs of eyes on the same code results in a more robust adapter. Second, with access to the code, Google can also make fixes as necessary to this open source repo. Finally, there's a nice side effect that you can see the code too. We like that this option provides you more transparency. Another change we're making is creating version builds of the adapter and putting them into distribution channels you're probably already using today, Bintray and CocoaPods. Hosting the libraries here will make it easier to add adapters into your project. Shown here is the Facebook adapter on Bintray. With one line change in your gradle configuration shown at the bottom of the screen, you can add the Facebook adapter into your app. On the right-hand side, you can see that there are multiple versions of the adapter. We test the adapter against each new third-party ad network SDK release and create a new version of the adapter for each release. This guarantees that there's always an adapter library that's compatible with the third-party ad network SDK version you're using. The versioning scheme of the adapter matches the third-party ad network SDK's version, with an additional number at the end in case we need to patch the adapter outside of a regular third-party ad network SDK release. Now that the adapters are on Bintray and CocoaPods, let's see what adding an adapter into your project looks like in practice. On Android, here's what your dependencies would look like if you wanted to include the Mobile Ads SDK and to support Facebook Audience Network within mediation. The first line is the Google Mobile Ads SDK, the second line imports the Facebook adapter, and the last line gets the Facebook Audience Network SDK. That's it. No more downloading jars from a website and importing them manually. For iOS, we host compiled builds on Bintray and use CocoaPods to refer to these downloads. The adapter CocoaPods have dependencies on the appropriate third-party ad network SDK. So on the iOS side, one line of code in your pod file, in this case pod Google Mobile Ads Mediation Facebook, gets you all the code you need to mediate to Facebook. We think that all these changes discussed so far are huge improvements, but it needs to be well documented so that you know how to use these new resources. The last big change we're making is to provide ad network specific documentation on how to set up mediation for each ad network. These guides are your one-stop shop for instructions on how to create a placement in the third-party ad network's UI, how to update your ad unit in the AdMob UI to configure mediation for that network, how to import the third-party SDK and adapter libraries, how to make any other ad network-specific changes that the adapter might require, and finally, how to set up testing for that network. So here are the 6 ad networks that we built first-class support for that you can start using today: Facebook Audience Network, Unity Ads, Chartboost, Mopub, AdColony, and Tapjoy. And we're aggressively working to expand this to additional ad networks. So that's it for mediation. Now I'm going to hand it over to my colleague Tang, who will talk about some new SDK features available for DFP publishers.
Hi, my name is Thang Duong. I am a developer advocate from the Google Developer Relations team. My role is to advocate for publishers who use DFP, AdMob, and IMA products. Today, I'm introducing 2 new features in DFP: Native Plus Banner and Creative Preview. The Native Plus Banner feature is a simple method that can improve the bottom line of your ad business. In your app, if you have to choose between native and banner ads, what are the reasons for choosing one over the other? Well, we already know that native ads are flexible. Publishers have the control to make the ads beautiful and engaging. That's why native ads have a much higher click-through rate. On the other hand, banner ads have been around for a long time. There are more advertisers using banners to drive up the auction pressure. As a result, banner ads have a better fill rate. To get the best of both worlds, we need to figure out how to enable banners to compete with native ads in the same ad request for the same ad units. I'm happy to announce that we can make it happen. This demo app can make native plus banner requests to load different kinds of ads into the same ad slot. First, I select native app install ad and content ad. These are 2 popular native ad formats. Then I select native plus banner. Now every time I click the request ads button, I can get either a native app install ad or banner ad or native content ad in return. To enable native plus banner request, DFP has added new ad unit settings and new line item settings. Lastly, we add a new function to the SDK for your app to make native plus banner ad request. The ad unit settings UI now allows you to combine native sizes with banner sizes. In this screenshot, the custom rendering is a native size that can represent all native ads. It is added along with a banner size 320 by 50. That's how you can make the ad units ready to serve both native and banner ads. While you only need the custom rendering ad size for your ad units, the line item sizes are much more granular depending on what your app can support. Common sizes are native app install, native content, native video app install, native content video ad. All of these line item sizes are compatible with the custom rendering ad unit size on the previous slide. To deliver native and banner ads to the same ad units, you can create one line item for native ad sizes and another line item for banner sizes. Then target both line items to the same ad units. At runtime, these 2 line items can compete against each other in every ad request for the same ad units. Alternatively, you can create one line item with all native sizes and all banner sizes. That's all of the changes on the DFP UI. Let's take a look at some new code in the SDK. In the current version of the Android GMA SDK, you can use the ad loader class to load only native ads. In this code snippet, I'm using the nested builder class to build a new instance of the ad loader. The new instance is set up to load native app install and native content ads. In the next version of the SDK, we add a new function to this builder class. The new function enables the ad loader to make banner ad request and return a publisher ad view. Hence, it is called for publisher ad view. Let's take a closer look at the new function. The first parameter expects a class that implements a new interface on publisher ad view loaded listener. This listener has a single callback on publisher ad view loaded for when a banner ad is loaded and ready to show. The second group of arguments is the list of different ad sizes to be included in the banner ad request. For example, the banner size is 320 by 50 and the medium rectangle size is 300 by 250. And that's how you can load different kinds of ads. But loading is only one part of the problem. The other part is what's happening after an ad has been loaded to your app. When is an impression recorded? Today, native ads already support delayed impression. In this mode, an impression is not counted until at least one pixel of the native ad is on screen. But banner ads record an impression as soon as it is loaded. When requesting native plus banner, you won't know what type of ad would come back. So, how will you know if you can preload the ad? To allow preloading with native plus banner, we are adding delay impression support to the banner ads that are loaded by the ad loader. This enables you to prefetch a native plus banner ad and then delay impression recording until a later time. Here is a demo of a banner ad in a recycler view. Because the ad was loaded by the ad loader, an impression is only recorded when the first pixel of the banner is on the screen. When you work with this new feature, here are a few caveats. First of all, the ad loader is designed to make either pure native or a combination request. It cannot make only banner request. If you need to request banners only, you can use the publisher ad view class instead. Second, the ad loader won't automatically refresh the banner ads. This is because the ad loader API isn't designed to fetch a single ad format. The native ad format will not refresh either. The expectation is that you will decide when you want another ad and then call the ad loader to load another ad yourself. Third, you cannot mix native mediation with banner mediation in a single mediation chain. This is currently not supported yet, but we're working on it because we believe that combining native and banner is a simple way that can improve the bottom line of your ads business. Coming up, DFB has a new feature called Creative Preview, which might sound familiar to most of you. For years, DFB users can preview creatives in a browser. But if you want to test out a new creative in your app on a mobile device, how would you do that? The first option is to create a new ad unit and change your app to request the new ad unit. This is not ideal because it requires app changes every time. Another option is to traffic the test creative to a production ad unit. This is risky because it may show up in production. There must be a better way to preview a creative on mobile. At a high-level view, the new feature is a series of steps that will allow you to push a creative to your app when you want to preview it. The creative can even be made inactive so that it will not accidentally show up somewhere else. There is a 5-step process to using Creative Preview in mobile apps. I will first talk about each step at a high level and then drill down into the details. Step 1 is to add a few lines to your app to open a debug menu. Step 2 is to open the new debug menu. You will go through this debug menu in the app to register your device with your DFB account. Step 3 is to specify which creative to be previewed in your app. And step 4, reopen the debug menu to start preview. And finally, you can make an ad request to preview the creative in your app on your test device. In the code, you first need to initialize the mobile ads. We recommend doing this as early as possible, such as in the onCreate method of your main activity. You also need to set up an event to open the debug menu. You can use any valid ad unit ID from your DFP account. In this case, I'm using an ad unit from the network 6499. In this code example, I have a debug button that I can click to open the debug menu. In a real-life implementation, you can call this method as part of your existing debugging flow. In step 2, you will learn how to link a test device to your account. From the code in the previous slide, my debug button opens a debug menu when I click on it. Then I select the Creative Preview option. The first time you click Creative Preview in our debug menu, you will be taken to the Google's login page. You must log in using the account that can access the network of your ad unit in step 1. Now I'm going to log into the network 6499. After login, you can enter a name for your test device. Once you link to your device, you can go to the DFP admin menu to manage all devices linked to your account. On the left navigation, you will need to select Access and Authorization. Here, you can make a device private or public. Making a device public means any users with access to your account can push a creative to your device. You can also delete a device to unlink it. In step 3, you will prepare the creative for pushing it to a linked device. First, you select the creative. Then, you select Preview tab. Next, you select the mobile option. DFP will show a dialog box. You will select In-app and then enter name of a linked device. That's how DFP knows which creative to be pushed to which device for previewing. We have done all one-time setup steps. 2 more steps are ahead of us. In step 4, you will come back to the app, reopen the debug menu. Select the same creative preview option as you did earlier. If the device has already been linked, the SDK will inform you so. Finally, in step 5, you just need to make a new ad request to load the test creative. And congratulations, you finished creative preview on mobile app. I hope that you can preview your next 100 creatives without having to create another 100 ad units or asking your account managers to change their trafficking 100 more times. Thank you for listening.